Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. We have learned this chapter of the function, and we have learned the operation of the function's order, exit, and close. In this lesson, we will continue to learn some operations of our function to withdraw orders. Withdrawing orders uses the function of strategy cancel. And the strategy cancel has two main parameters. One is ID, and the other is when. The ID is the ID of the order we want to cancel. We can recall the strategy entry of the entry function we learned before. That is, when placing an order, we need to set an ID for the order operation of the strategy entry function. What is the ID used at this time? That is, when withdrawing the order, we can pass the ID into the parameter of the function to withdraw the previous entry order. If there is no transaction, it will be cancelled. Similarly, some of the closing orders we place, that is, exit orders, for example, we use the strategy exit function to place some exit closing orders. When it is not closed, we can also use the specified ID to cancel the order. The other parameter when refers to the condition that we want to cancel the order. That is, the condition we want to execute the cancellation function. When shall it execute? Let's use a simple example to illustrate. For example, I write strategy cancel demo here. Don't forget to quote though. And then we set the number of parameter positions scale in. We set it to 3 here. And then we declare our variable is stop by using the var keyword. And then initialize it to false. Then we judge the isStop tag. If it's true, we will let the runtime error function throw an error and let it stop. Which is also for our ease of observation. Then we can simulate 3 entry orders. We place 3 limit orders. set the price lower and then let the order be in a state that cannot be closed. Here we use the function strategy entry to place an order. We name the first order as long 1 here. And then we specify the direction to go long. For example, if I want to place an order of 0.1, we specify the parameter limit as 1. And we can copy this line of code directly. Then we modify this long 2 and change it to 0.2, limit equals to 2, and here long 3, 0.3, and limit equals to 3. We can see that the price we specify is a relatively low price. And it is almost impossible to make a deal because when we test, the price is tens of thousands yuan, which will certainly not make a deal. Then we withdraw the order because it will not make a deal. It's a planned order actually, which is in the state of scheduled execution. So we withdraw the order. Then we judge that if it's not the bar stage of the historical K line, and we will withdraw the order when close is less than open. Here we write close less than open. That is to say, when it is a negative line here. Here we can call our withdraw function strategy cancel. Then we pass in the ID of the order we want to cancel, such as order long 1. Here we pass in long 1. And we can copy it. Copy line 20 here. Change it to long 2 and long 3. After we executed the commands of all these 3 order withdraw, we set is stop to true. And then we click backtest to check whether these 3 orders will be cancelled. Because these 3 orders are in the state of planned orders, they are not really triggered to open place orders because they are limit orders with specified prices. So on the chart, there is no real trade order mark. But if we place an order before the entry order is cancelled, we can see the planned order information of the entry order in the entry order. Let's go back to the code page. Because we wrote that after the planned order is issued, of course, we can only issue the planned order in the real-time K-line bar stage. And then we judge that if we go to the real-time bar K-line stage and withdraw the order in the negative line, here we change the condition of withdrawal and we write false here. That is, make it false all the time. That is to say, when the following order withdrawal operation is not executed, and then we backtest it. We can see that in the scheduled orders, there is a planned order hanging there. That is in the state of pending. The prices are 1, 2, 3 respectively. Because the cancellation operation cannot be executed because it is constant false. And the following will not be executed. If we change it to the condition we just set, close more than open. Oh, sorry, it's close less than open. When it is a negative line, we can cancel the order. Click backtest again. We can see that the plan order is gone in the status bar. Because we just placed the plan order and executed the cancellation operation, and all of these orders are cancelled. And then in the log message column, we can see that when there is a cancellation, there will be a corresponding cancellation record. We can see that the cancel function is executed and it will show which ID of the order is cancelled. We cancelled long 1, long 2, and long 3. In this way, the cancellation operation is realized and then stop, so that the strategy stops. So the function strategy cancel is very simple. That is, we specify the ID of the entry order where we need to withdraw the order, and then we will withdraw the order. In addition to specifying an ID to cancel the order, we can also cancel all orders. That is, all pending orders will be cancelled. The function is strategy cancel all. And we also use an example to test it simply. The test strategy is similar to the previous one. We also need an isStop tag. And then let it stop immediately after executing the structure we need it to execute, so that we can observe it easily. And we are also going to use 3 entry orders here, which are long 1, long 2, and long 3, and the prices are 1, 2, 3, which are all limit orders. That is, it will not be closed immediately. Then, in the position of order withdrawal, we change the order withdrawal function of a specific order withdrawal ID to the function strategy cancel all. That is, let it cancel all orders. Do not specify the ID. All hanging orders will be cancelled. And we click backtest. Let's see the running results. We can see that in the log message column, we didn't specify any ID of order withdrawal, but the information cancel all was executed, and these orders are executed through the function cancel all, which cancels all the 3 pending orders here, long 1, long 2, and long 3. This is the order cancellation operation. When we have some orders that are planned to enter, it will execute the function cancel all these planned orders regardless of their specific ID, and all orders will be cancelled. Let's learn the last important trading function, that is the strategy order function. It's an order function. It is almost exactly the same as the strategy entry function. The biggest difference between them is that the function strategy order is not affected by the parameter position scaling in. For example, the number of parameter position scaling in we set in the example just now was 3. That is to say, we enter the market 3 times in the same direction at most. The function strategy entry is affected by the number of parameter position scaling in. If we enter the market for the 4th time by using strategy entry function to place an order, it will not place an order to trade. But the strategy order function is different. Because it is not affected by the parameter position scaling in, it can place orders without limitation. We can also use a simple example to demonstrate here. Besides, the parameters of function strategy order and the strategy entry is exactly the same. It includes ID, which is also used to define the order ID, which is the identifier of the order. Then there is a direction, which is used to define the order, which is used to specify whether the order is a buy order or a sell order. And then there is quantity to set the order quantity. And parameter limit. Parameter limit to set the order limit specify its price, specify its stop-loss price, and so on, including specifying the execution conditions and the parameter when. These parameters are basically the same as those of function strategy entry. Here we use a simple example. Let's look at how we can write a simple trading logic similar to a grid transaction through the function strategy order. Let's write the specific code. First, we use var IP keywords to declare a variable begin price. And then we initialize it to -1. Which means that the price is invalid when it is -1. That is to say, when we find that the price is -1, we do nothing. Then we initialize the price for it. We use the if conditional statement. And then we can judge that when it is not in the stage of the historical K-line bar, we perform an operation on it. And then when begin price is equal to -1, or close minus begin price is greater than 1000. Here we use the function math absolute. That is when the current price exceeds the starting price range by 1000. We reset the price. There is also a situation when all the orders entered are closed. That is when the built-in variable strategy open trades equals to 0. At this time, we also reset the begin price. If either of these two conditions is met, we will modify begin price. Modify it with the assignment operator here. And assign it with the latest close built-in variable. That is the latest closing price. Here we ignore the case that we just judged when the initial price is equal to -1. Then we initialize begin price with the current price. The other is to reset the initial price of the grid when the current price and initial price exceed 1000 and there is no open position. We only consider that when the close is greater than the begin price. We do not consider that when the begin price is greater than the close. That is, when the price is a downward state, we need to change this place. Here we need to use a function to judge. We use the function math absolute to calculate its absolute value. That is, when the absolute value of the difference between close and begin price exceeds 1,000. That is, when the price difference is too large and there is no current position, we can move the initial price of the grid to the latest closing price. After the real-time K-line bar stage, if we initialize the price of begin price, we can use the loop operation to arrange the grid. Here we use for to write a loop. And then we set the variable I equals to 0 initially. Then we let it execute a loop at 20. That is, we make a loop for 20 times, which is equivalent to create a grid with 20 nodes. And this time we can use the function strategy.order to place an order. Because we did not specify the number of parameter positions scaling in, if we use the function strategy entry to place an order, we can only place an order for once. So here we need to use function strategy.order. After placing an order, the first parameter is the order ID. We use by. Plus I as the order ID. When I equals to 0, it's by 0. Then when I is 1, it's by 1, and so on. That is, the order ID name of each order entering the market is different. And then we specify its trading direction. First, we do the going long order. And we use the built-in variable strategy long here to specify the function to go long, and then let it place an order of 0.01 quantity each time. Then we use limit to specify the price. We use begin price to subtract I multiply to hundreds here. Here is subtract, not plus. That is, the distance of the grid on each node is 200. We can see that when I equals to 0, We place an order at the begin price position. When I equals to 1, we subtract 200 from begin price and then subtract 400, 800, and so on. Pend the order of the grid in this distance range. When the grid enters the market, if we want to place an order, we also need to specify a condition, that is, grid for going long. We want to place an order to wait to fill at a low price, which is going long. So we need to judge whether the current price is higher than the current pending order price. If the current price is lower than the pending order price, then it is definitely unnecessary for this order node to enter, because the price is already lower than the price grid point of the current plan to place orders. That is, the price has been through this grid point and has reached the next level. And this time we will not place grid orders at this node. So we also need to write a parameter when in this place. Making full use of the parameter when in the function strategy order to specify its trading conditions. We set the parameter when and then we copy the price of the pending order. We need to use parentheses here. And then we can judge if the price condition of the pending order is less than the current close. That is, less than the current real-time closing price. We will let it perform the pending order operation. After pending the entry order, we will also pend the exit order. That is the exit order of this node. We have learned about the exit order before using the function strategy.exit, which is a very convenient order closing function. We can directly specify its ID, name it as cover by. We also use the variable I to mark. Their variable I is synchronized here. The orders are named as by 0 or by 1, and the corresponding closing order is also named as covered by 0 or covered by 1. After we define the exit order ID, we also need to pass in the long position to exit. That is, the exit identifier. Here we set by +1. Sorry, it's by +I here. In other words, what we need to specify is to let the corresponding entry order exist. If we want to buy +1 +I, such as by 0, here is also by 0. If it's by 1, is also by 1. The order parameter quantity of the exit is the order quantity, which is the same as above. We also set it to 0.01. Okay, let's set the exit parameters. We need to specify the profit. That is 200 points of profit will lead to exit. So the design is very simple here. This line is responsible for entry. After the entry or condition order for exit will be displayed at the same time, because if the entry condition order is not closed, the exit condition order will not be executed. We have also talked about it in the last tutorial video. That is, here it can append an exit condition order directly, and the stop profit price we set is 200 points. Then we will continue with the direction of going short. If the price increases, we will go short, and if the price decreases, we will go long. We use the function strategy.order to see the going short direction. Set sell here. And specify its order ID as sell plus I. For example, the first order is sell 0, and the second order is sell 1. Then we specify the direction as strategy short. And we set the order quantity in the short direction as 0.01 here. Then we specify the price and set the parameter limit as begin price plus I multiply 200. That is, the order closed is hung at the current price. That is, the price of placing order increases in turn to specify the selling. Also, in order to avoid repeated opening positions, if the price has risen to higher than our current pending order price, and then the current price has crossed the current selling price line, it is unnecessary to place an order at the current node. At this time, we need to judge that the direction of the price is the same as that of the going long position. We can copy the current set price limit. And then we require that the order price must be greater than close. Order can only be placed when the price is greater than the current price. And here, don't forget, is plus. After we specify the entry order of the going short order, we need to prepare the exit order of the going short direction. We also use the function strategy.exit. Here we use cover cell plus I. And then we specify which going short order entry we are closing. We also specify the ID, the same as above. Cell plus I. Then we specify the quantity of its exit order quantity at the closing position, which is the same as the entry order quantity, 0.01. That is, we can close the position as much as we open the entry order position. Then we specify its profit. Its profit point, and the parameter profit is also specified as 200 here. Well, we have designed a grid trading logic through such a few lines of simple code. And we click the backtest. On this page, first we select the backtesting time from 2021 March 1st, apply, to 2022 August 30, apply, and set the backtesting period. Here is 1 day, and set it to here, tick model. Set the pricing accuracy to 0. That is, the price per jump is 1, because the grid needs to monitor the current price in real time. If the current price meets the condition, the position will be opened or closed immediately. We click backtest. Oh, it reports an error. Let's go back to our code page. Here we can see in the line 13, we lost the equal sign. And let's click backtest again. Since we have set the tick model just now, it will be very slow. So we change it to bar model to make it faster. If we set it to the real-time price model, if we set it to the tick model, the backtest speed will be slow. We change it to bar model here. If it's the tick model, because there are many monitored orders, such as our strategy, which has more than 20 monitored orders, and it will be slow when it's tick model during the backtest. But if the strategy is a robot grid, we must choose a tick model. Here we choose bar model to make the demonstration faster. Well, we can see from the chart, grid trading starts at the beginning of the price. And then sell when the price is high and close the position when the price returns. When the price is low, and sometimes the short position is completely closed, a long position will be opened. That is, the characteristics of grid trading are that when it encounters large increase and decrease range, it will have a large retreat, and there is also a possibility of floating losses. When in a violet market, we can also get some profits. Of course, the grid strategy is also afraid of violent unilateral market. If it keeps increasing and the price doesn't return, there could be a relatively large retreat, a loss at some point, which can also be seen in our curve. And there will be a relatively large floating loss. This is one of the characteristics of grid trading. We need to have an understanding of the characteristics of each strategy. If it does not mean that any strategy is opponent or win-win. Each strategy has its own direction and field of expertise, such as CTA strategy. In this relatively large trend market, we may be able to get a better profit. If we use grid strategy in a volatile market, we may gain profits. Each strategy has its own focus. For us traders, strategy is just a tool for trading. It does not mean that quantitative trading and program trading are a kind of stable technology or means. We also need to treat quantitative trading and program trading objectively. In fact, there is not much difference between quantitative trading and program trading and manual trading. They are both trading, and the core of trading is our human beings. What tools to use depends on our trading habits and risk preference. Maybe some users don't like the grid strategy. Maybe some users can use the grid strategy better. Everyone has different trading ideas. So, after we have learned this chapter, we can use a very short code to build a grid strategy. Therefore, it can be seen that compared with other languages, Pine language is very simple and easy to use. So that's all for today's lesson. If you think our video tutorials useful, don't forget to like, follow, and repost. Thank you all and see you next time.